Hey, good morning, everyone. Don Yellis from Emerson. I'm in Sydney, Ohio at the Copeland plant. Hey, a week or so ago, we talked about liquid floodback. Liquid floodback, to me, when I think of liquid floodback, I immediately think that the refrigerant's not boiling off for whatever reason in the evaporator. Okay, the TXV's not sized properly. It's not working properly. More than likely, or 9 times out of 10, if you will, 8 times out of 10, airflow, 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 airflow. Can't emphasize that enough, airflow. But for whatever reason, we're getting liquid refrigerant back to our vapor pump, which is not good, obviously. Okay, when we see that, we see the liquid refrigerant act as a solvent in the oil. It loses that lubricity, whether it's a reciprocating or a scroll set. Now, floodback, liquid floodback is when the compressor or the equipment is running. Today I want to talk about flooded start because that can be a little confusing with the word flood. Now, liquid floodback, the system is running. Flooded start is off-cycle migration. So you have vapor refrigerant. Remember the second law of thermodynamics on a very layman simple term, hot always goes to cold, right? We all know that. High pressure goes to low pressure, hot goes to cold, yada, yada, yada. So the vapor refrigerant's warmer. It goes to the condenser outside. Depending on the length of that refrigerant line set and the difference in the temperature swing between the outdoors or the condenser and the evaporator, if you will, it depends on how fast that migrates to that compressor. And when that vapor refrigerant gets down inside that oil, it then condenses. You go to start it, the explosion, that liquid refrigerant wants to flash off. You have a view explosion, and you have a lot of times you have broken parts. We take a slug, okay? Doesn't matter what refrigerant. It doesn't mean that you can't have liquid refrigerant going back to the compressor, whether it be a scroll or reciprocating, and damage the scroll set. But it takes a lot longer, and the first thing you're going to see is that dilution of that oil, and it loses its lubricity, okay? Keep in mind that at the top of that scroll is the hottest point of the compressor, that discharge area, okay, that discharge gas on the top of that scroll. It's also closest to the thinnest wall of oil in the whole compressor. In the scroll set, it's between those flanks, okay? And I have one here to show you. So this is the thinnest film of oil around that scroll set on those flanks. The sidewalls are what we call flanks. The very top of it is the tips. Copeland, by the way, doesn't use a tipping material, and that's why ours is so much more efficient, or very efficient, okay? Ours wear in, they don't wear out. That's our motto, okay? Now, if you have liquid or a flooded start, okay, this is what it looks like. By the way, those ports in there that you're seeing, this happens to be a two-stage scroll, and that's where those ports would come through there. That gas would let out for your first and second stage. Now, if you have a flooded start, this is what happens when things go seriously wrong. So this is the same top scroll, fixed scroll, the very top of the scroll set, and you can see those flanks are completely knocked off. It took a slug. This would be a refrigerant, a flooded start, okay? It exploded. That refrigerant came up through that shaft, got in that scroll set, and our vapor pump turned into a hydraulic pump, similar to what we have on a flooded start. But again, this is a big explosion on startup, okay, that flashing off, where the liquid floodback is a gradual. Again, we're losing our lubricity. Again, whether it's recip or whether it's a scroll, we're at the hottest area of our compressor, that discharge area, right up by that discharge gas, okay, hottest part. And the thinnest wall of oil on a recip is that cylinder wall between the piston, okay? So we have the hottest heat in the compressor, and we have the thinnest wall of oil, thinnest film of oil, okay? We start to lose our lubricity. So anywhere around 300 degrees or above, we start to cook that, okay? The viscosity gets very, very thin. We thin that out, okay? But this just shows you, here's the scroll set, by the way. I don't know if I can show you that or not. This is the scroll, knocked all the flanks off there. This is what it's supposed to look like, okay? And this is what happened to that scroll. These are pieces of the flanks that got knocked right off. This compressor, by the way, just came out of a teardown area. We borrowed it. Okay, so I just wanted to do that little demo. We're actually doing a larger film on this same a different topic, but similar to that. So that's your fun fact for today. Again, flood back, units running. Okay, liquid refrigerant for whatever reason is not boiling off in the evaporator. Okay, flooded start, it's off cycle migration. One's running and one is not. Okay, so be aware of that. Now, what's the solution to a flooded start? I hear what you're saying. Crankcase heater. If it's not cold out there, that warmer vapor refrigerant doesn't want to go to cold. Hot doesn't want to go to cold, right? So if we warm that crankcase up, it doesn't want to go out there. Or we do a solenoid, a liquid lined solenoid pump down and move it over to our condenser or in our receiver, and then it can't migrate on that off cycle. Now, off cycle could be a whole season in air conditioning. You know, it could be from winter to spring, and off cycle migration could be 4 hours on some systems. It just depends on what the setup is and the temperature difference between that condenser and that evaporator. What wants to make the what makes it want to migrate outside of the condenser. Okay, I got tongue tied there. Well, that's it for today. I'm Don Gillis at Emerson. If you're on call this weekend, be careful out there. Make sure you take care of each other. Share the knowledge, and I will see you next week. Okay, thanks a lot. Bye.